I'm gonna teach you how to test all types of SMD resistors using the multimeter. But first, let's answer some questions. What is SMD resistor? What is the difference between SMD, SMT, THT, and BGA? What are the types of SMD resistors? What are the different symbols of SMD resistors? How to calculate SMD resistor codes? Definition: a resistor is an electrical component with two leads that regulates and limits the flow of electrical current. It can also be used to provide a specific voltage for electronic devices, such as transistors and integrated circuits. In other words, it can be used for protection and current control. So let's see what is the difference between SMD, SMT, THT, and BGA. So the surface mount device SMD stands for an electronic component mounted on a PCB, such as transistors, MOSFETs, resistors, capacitors, integrated circuits, etc. In contrast, surface mount technology SMT refers to the process of placing electronic components on a printed circuit board PCB. THT stands for Through Hole Technology. It involves inserting components, terminals, or leads into drilled holes in the printed circuit board PCB. The BGA stands for Ball Grid Array. It is a type of surface mount packaging used to solder big chips such as microprocessors, GMCH, ICH, and other integrated circuits into PCBs. It uses a grid of solder balls to make electrical conduction between integrated circuits and PCBs. Now let's see the types of resistors. The first, general purpose SMD resistors. It is a standard resistor that regulates and limits the flow of electrical current in an electronic circuit. The second, SMD network resistor. It is a combination of two resistors or more. Its purpose is to gain space in electronic boards. Jumper resistor or fuse resistor. Generally, this resistor equal to 0 ohm. This type of resistor is used as a jumper in laptop motherboards and mobile phones. Thermistor resistor. The resistance of this type of resistor depends on the temperature. In other words, it is a temperature sensitive device. The term thermistor is originally a combination of two words, thermal and resistor. There are two types of thermistor resistor: NTC thermistor resistor or negative temperature coefficient, and PTC thermistor resistor or positive temperature coefficient. Then current sense chip resistor. Current sensing chip resistors or shunt resistor is used for current sensing under the high current circuit. So as you can see here, this is the picture of SMD resistors. So let's begin here. This is the fuse resistor. Okay, you can find 3 zeros or 1 zero in the body of resistor, means fuse resistors. Its resistance equal to 0 ohm. Then here, as you can see, we have the network resistor, as you can see. So the network resistor is a combination of 2 or more resistors. Here we have 3 resistors, as you can see. So this bands means resistors. Okay, so the value of this resistor equal to 1000 ohms. Okay, so we have here the first digit, the second digit, and this is the multiplier. 2 means 2 zeros, means this is a 1000 ohm or 1 kilo ohm. So here, as you can see, this is thermistor resistors. Okay, you can find thermistor resistor in a black color or in a brown color, as you can see. Okay, so this resistor, as you can see, is a light dependent resistor or a photoresistor. So over here we have the standard resistor. So this and this and this, all these 3 resistors are standard resistor. So the value of this resistor is 1 mega ohms. Okay, 1 mega ohms, because we have the first digit, the second digit, and here we have the multiplier, means 5 zeros. Okay, 5 zeros with 10 means 1 mega ohms. Okay, here, as you can see, we have 64R. Okay, 64R means 64 ohms. We're gonna see in the next slides how to calculate the resistor codes. Here, as you can see, we have 2R3 means 2.3 ohms. So these 2 resistors are current sense resistors. Okay, we find these types of resistors in laptop motherboards and also in mobile phone motherboards. Symbols of resistors. So as you can see here, all these symbols are for resistors. Okay, for example, for this, 2 symbols are for the standard resistor, as you can see. So basically this is a US symbol and this is universal symbol. Okay, so these 2 symbols for standard resistor. These 2 symbols, as you can see, are for the light dependent resistor or the photoresistors. We have here 2 arrows here. Okay, and this symbol is for the network resistor. As you can see, we have here 4 resistors. So the network resistor is a combination of many resistors. Basically, we use the network resistor in order to gain the space in the motherboard. And for these 2 symbols, as you can see, are for the thermistor resistor. Okay, the thermistor resistor. Now we're gonna see how to calculate the resistor code. So generally the SMD resistor can have 3 or 4 digits. The last digit represents the number of zeros. The letter R shows the position of the decimal point when it is placed before or between digits. Okay, so generally you can find 2 kinds or 2 types of resistors. You can find a resistor with 3 digits or 4 digits. So always the first digit and the second are fixed numbers, and the 3rd one or the 4th one for this type of resistor is the multiplier. Okay, so here we have the first digit, the second digit, and the multiplier. Here we have the first digit, the second and the 3rd digits are fixed, and the 4th is the multiplier. So let's see some examples here. So here, as you can see, if you find this code in the resistor, 101 means 100 ohms. So 1 means we will add 1 0. Okay, so 102 means 1000 ohm. As you can see, the multiplier is 2. Here we will add 2 zeros equal to 1 kilo ohms. 123 we will add 3 zeros, so equal to 12 kilo ohms. 155 we will add here, as you can see, 5 zeros, means 1.5 mega ohms. So for the resistors with 4 digits. So the first digit, the second and the third are fixed numbers, and the 4th digit is the multiplier. Here we have 1, we will add 1 0. Here we have 2 zeros. Here 4 zeros. Okay, so when you find R, so as we have here in the definition, the letter R shows the position of the decimal point. This is the decimal point, as you can see here. Okay, when it is placed before, okay, like this example, or between digits, like this example. Okay, so here we have R10 means 0.1 ohm. 5R4 means 5.4 ohm. 7R50 means 7.5 ohm. 50R0 means 50 ohm. So we're gonna see right now a note, as you can see. Sometimes instead of the letter R, you may find letter K or the letter M. All that letter shows the position of the decimal points, but with different units. So letter R refers to ohms, okay? Letter K refers to kilo ohms. Letter M refers to mega ohms. So let's see some examples. Here we have R10 means 0.1 ohm because we have R. 5R4 equal to 5.4 ohm. So here we have K10 means 0.1 kilo ohm. 5K4 means 5.4 kilo ohm because we have K. And for the M10 equal to 0.1 mega ohms. 5M4 means 5.4 mega ohm. So right now I'm going to teach you how to test the resistors, SMD resistors, using the multimeter. So I want to just add before diving into practical that to measure or to test the resistors, you can use the probes of the multimeter in the both sides. Means you can use the black probe here and the red probe in this side, or the red probe in this side and the black probe in this side, because the resistor is not polarized like the chemical capacitor or electrolytic capacitor. So now let's see how to test the SMD resistors. So in this lecture I'm going to show you how to test all types of SMD resistors using the multimeter. Of course we're gonna select the resistance option or the ohm option in the multimeter. So as you can see here we have the auto range. So this is an auto range digital multimeter. Okay, of course you can use also this kind of multimeter where we have scales and gradation, and you can choose any scale you want. So the first resistor that we're gonna test is this. As you can see we have 1 0 0, so the third number is 0, so the multiplier is 0. The resistance of this resistor is 10 ohm. Okay, so let's check it. We should find 10 ohm in the multimeter. So as you can see in the multimeter we have 10.3 means 10 ohm. Okay, so this is a good resistor. Let's check this resistor also. We have 471, the multiplier is 1, so means 470 ohms. 470 ohms. So let's check. As you can see we have 465.1 means 470 ohms. So this is a good resistor. Okay, as you can see here, this is a network resistor where we have 1 0 and 3. So 3 is the multiplier. 3 means 3 zeros. This resistor equal to 10 1000 ohm or 10 kilo ohms. Okay, 10 kilo ohms. As you can see, 9.93, about 10 kilo ohms. As you can see in the multimeter, we have 10 kilo ohms. So let's check this resistor also. So we have 3 zeros, means this is a fuse resistor. Okay, this is a fuse resistor. We have here in the multimeter 0.1 or 0.2, means 0 ohm. So this is a good resistor. Okay, as you can see in the multimeter, the value is correct. Let's check this. As you can see, we have 4R7. As I told you before, R means the decimal point. This should be equal to 4.7 ohm. 4.7 ohm. As you can see, we have 4.8 ohm. So this is a good resistor. Okay, this is a serviceable resistor. So let's check those resistors also. As you can see, we have 105. The multiplier is 5, means 5 zeros. We will add 5 zeros. This should be equal to 1 mega ohm. 1 mega ohm. So let's check. So as you can see, we have 0.996 or 97, means 1 mega ohm. Okay, so as you can see, the unit is the mega ohm. So this is a good resistor. 1 mega ohm. So this is a good resistor. So let's check this resistor also, the same value. We should get 1 mega ohm. As you can see in the multimeter, we get 1 mega ohm. So let's check this resistor. As you can see, we have 150, means 15 volts. Okay, 15 volts. We should get 15 volts. As you can see, we have 15.5. As you can see, this is correct. So this is a good resistor. Here we have another resistor with 754. So the third number is the multiplier. 4 means 4 zeros. This should be equal to 0.7 mega ohm. As you can see, 0.754 mega ohm. Okay, as you can see in the multimeter. Here we have another network resistor with 3 numbers. We have 3, 2, 22. So the third number is 2, means 2 zeros. This should be 2.2 kilo ohm or 2222 ohms. Let's check. We should get 2.2 kilo ohms. As you can see, we have 2.90, means 2.2 kilo ohms. So this is a good resistor, as you can see in the multimeter. Here we have another fuse resistor. As you can see, this time with 1 0. Of course, with the same working principle, we should get 0 ohm. As you can see, we have 0.3, means 0 ohm. Means this is a good fuse resistor. Okay. Here we have another resistor. We have 152. So 2 is the multiplier. So this should be equal to 1.5 kilo ohm. 1.5 kilo ohm. As you can see in the multimeter, we have 1.45, means 1.5 kilo ohm. This is a good resistor. Okay. Here we have another network resistor. We have 681. Okay, means 680 ohms. Because the multiplier is 1, we will add 1 0 to 68, means 680 ohms. We should get 680 ohms. So let's check. As you can see, here, this is a current sense resistor. So basically, we should find here 0. As you can see, we have R020. As you can see, we have 0.1 or 0.2. This is a good resistor. Here, as you can see, we have another resistor where we have, as you can see, 2R2. This should be 2.2 volts. Okay, because R means decimal point. As you can see, 2.4 ohms. 2.2 ohms. As you can see in the multimeter, 2.4 ohms. This is a good resistor. Here we have 1R0, means 1 ohm. This should be equal to 1 ohm, because R means decimal point. So this resistor should be 1 ohm. Let's check it out. As you can see, we have 1 ohm, okay, 1.1 or 1 ohm. This is a good resistor. So this is a motherboard for the mobile phone, and over here we have two resistors. As you can see, we have two current sense resistor. We have R010. This should be equal to 0.01 or 0.1. Okay, so this is basically like a fuse resistor. We should find 0 ohm or 0.1 ohm. As you can see, we have 0.1, 0.2. This is a good current sense resistor.